Hello, here is question 4. A cylinder barrel with a diameter of 2 feet contains a collection of rainwater. So it's collects a lot of rainwater in this barrel. As shown in the figure above, the water drains out through a value not shown at the bottom of the barrel. The note show that there's a hole in here at a rate of change of height of the water in the barrel with respect of time t is negative 1/10 square root of h. So you can say this is negative. This means that the loss of the water. So where h is measured in feet and t is measured in second. The volume of the cylinder with the radius and height, h is v equal to pi r squared multiplied with h. This thing we learned in the algebra 1. So actually they don't need to remind us this thing. So find the rate of change of volume of water in the barrel with respect of the time when the height of the water is 4 feet, indicates the unit of the measure. So let's do this. Because we want to find the rate of change, want to find the rate of change of the volume of the water. So we need to find the volume of this barrel. So V equal to pi r square of h, and also is equal to, because the diameter is 2, the radius will be 1. So this pi 1 square of h will be just a pi h. The rate of change of the volume, this means that dV, the dV dt, the dV dt. So this also means, the d pi h f dt. So this thing also equal to the pi multiply with the dh dt. It's already said that when the water is full, height of the water is full, so we just need to find the dh dt, when the height is equal to 4, the h equal to 4. And we need to find the answer. When the height is equal to 4, the negative 1/10, the square root of 4. So this will equal to negative 0.2, and we substitute it back to our answer. So the dV of dt, so the dV of dt of h equal to 4, that will equal to negative 0.2 pi, or we'll say this is negative pi over 5, and it's because it's the volume, so we will have a feet cube per second. This is the change of the volume for the first question. Okay, let's check question B. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Let's check this one. It means that for velocity as acceleration. So velocity of this thing, and we need to find the second derivative of this thing. And let us take this out. dh dt. So we need to find the second derivative of the dt. This line is not straight. Make it like a straight line. The dh of the dt, dh of dt. This is equal to the d second h of dt squared. That's equal to, it's a negative 1/10. We don't need to derive it again. So this is 1/2 of d of dt. We can write this thing. It's a 1/10 of the dh 1/2, power of 1/2 dh, then multiply with dh dt. So this thing is basically the chain rule. So we write it down like a 1/10 multiply with 1/2 multiply with h negative power of negative 1/2, multiply with dh dt, and the dh dt is equal to, as we can see the dh dt in here, dh dt is equal to the 1/10 square root of h. So the square root of h and the h power of negative square root of negative power of 1/2. This is the positive power of 1/2. So they can eliminate each other. So they will just be 1, and this all thing multiply together. This will be 1/200. 1/200 positive. So we can find our dh dt second. Second dh dt. The dh dt. Let me copy this thing. The dh dt second derivative is equal to 1/200, and this is also bigger than 0. And we can say this is bigger than 0. And that means that let me write this, put this thing in here, and this means that the water with respect to time is increasing when h is bigger than 0. When h is bigger than 0. So we can see, when the h is equal to 3, when h is equal to 3, the height of the water increasing. The height of the water with respect of time increasing. So if that's a problem, you will find in the real test. You need to write the full answer. Okay, let's see question C. For the question C, we need to find the height of the use a separate variable to find the expression for h in terms of t. So in here we need to copy this thing down and use a separation of the variable to find the antiderivative. So we put both h and dh in same side. We will find a square root of h 1 and dh in the left side. We divide it by square root of h in both sides, and we multiply with dt. It's 1/10 of dt. Then we integral both sides. Of the square root of h 1 dh equal to integral of the 1/10 of dt. And for the left side, it's equal to, because this is the h of negative 1/2. That's the inverse power rule will equal to the plus of 1 and divided by this one plus of 1. 1 divided by this thing plus a 1, so this will be a 2, right? This will be a 2, and this 1/2 plus a 1 is a 1/2, and this will equal to this is the negative of 1/10 of h plus a c. And we need to find the c, so we put this t equal to 0 and h equal to 5 in. So we have 2 square root of the 5 equal to, because t is 0. Sorry, it should be t in here. So should be t in here. And the t equal to 0, we substitute in. So this 0 plus c. And c is equal to 2 square root of 5, 2 meters square root of 5. So we put it in. So let me copy this thing. This will equal to the 2 multiplied square root of 5. So h of 1/2 square root of h will equal to the negative 1/20 t plus square root of 5, and the h of t will equal to, we square both sides of negative 1/20t plus square root of 5 square. Yeah, that's a final answer.